Hi folks, this is Murphy here. I want to do a brief video, I hope brief, on the second half of section 1.3, midpoint and distance formulas. That second half being on the distance formula part. I'll do a brief recap of the midpoint formula and the process of deducing what the midpoint is, just because it's on the same page, so we can. But the distance formula works along a similar fashion in terms of what we need to find and the logic behind it. So to find the midpoint, remember that for the midpoint formula, which is this, which looks a little spooky maybe, it's actually not as bad as it seems, and the formula itself is very intuitive. The way we should think about it is that it's the average of the x's, comma, the average of the y's. So why are we taking the average? Think about it like, remember what the midpoint is, as the name would suggest, is that it's the halfway point, and any number that's between two other points is going to be their average, whether that's a singular number on a number line, or whether we're dealing with a point on the coordinate plane, in which case we do the same thing twice, once for the x's, once for the y's. So the distance formula, just to kind of show the logic of the midpoint formula, again, I could think of the change from A to B in terms of its horizontal distance and in terms of its vertical distance. So I went from A to B by traveling 8 units to the right, and then, let's see, negative 7 to 5 is 12 units up. So 8 and 12. Think about this already. I think if I just presented this triangle to you after doing the Pythagorean theorem exercise that I gave you, you'd be able to find what the hypotenuse is here, AB. Because when we actually break any segment into its vertical and horizontal components, unless that segment is vertical or horizontal itself, what I end up doing is creating a triangle. Remember, this class is pretty much all triangles. This is why. So we could use this to our advantage. If I break this up into vertical and horizontal, what I have is a triangle where the segment that I'm trying to find the length of is the hypotenuse. So I could basically set this up and say 8 squared plus 12 squared is AB squared, and solve from there. But even then, what if I want to generalize this formula? What if I'm just talking a generic point AB? Like, what if I don't know the coordinates of points A and points B, and I want to talk in general terms of x1, y1, x2, y2, and come up with a formula like I did for the midpoint? Well, first of all, it is important to recognize that the distance between 2 points is the length of the segment. The distance from A to B is also the length of segment AB. So essentially, if I ask you for either of those things, I'm asking the same question. And it's also important to recognize that the formula is based on the Pythagorean theorem. So let's riff off that. Let's go with that first and kind of recognize that to find this leg length right here, to find that it was 8. I'm sure what you did in your head is you counted from negative 5 to 0, and that's 5. And then from 0 to 3 is 8. So 5 and 3 is 8. And then that's how you did it. But remember that we talked, this actually had a name, as silly as it is because it's so obvious, but there's something called the ruler postulate that says if I want to find the distance between any 2 points, I take the absolute value of their difference. So if this is my x1 and this is my x2, I can take the absolute value of the difference of x1 and x2. This whole absolute value bars thing ensures that the order in which I subtract them doesn't matter. I'm getting a positive answer the entire time. Same thing with the y's. This vertical leg is going to be y1 minus y2, and then its absolute value. I could have done y2 minus y1 if you're thinking like slope. That's fine. But remember, the absolute value of the difference is going to come out to the same thing anyway. So that's that. So imagine now I square this quantity and I square this quantity. According to the Pythagorean theorem, a squared plus b squared equals c squared, where the c in this case is segment AB squared. So what if I take this and I put it in an equation? Like, I'll throw that equation right here real quickly. I can say AB squared is equal to, actually, you know what? Seeing as I'm squaring this quantity, I really don't need the absolute value bars, do I? Because if I square a positive thing, it still comes out positive. So let's actually back up a second. And I don't need the bars anymore. I could just turn it into normal parentheses for grouping. x1 minus x2 squared plus y1 minus y2 squared. Sorry for all the clicking, but this is how I avoid using a trackpad. I have an actual mouse plugged in this time. So if I want to solve for this hypotenuse, in other words, if I want to solve for the segment length AB, I can take the square root of both sides. I hope you're following, by the way. Don't just wait for the final product. It's actually really important that you understand the logic behind this. If I square root both sides, root AB squared just gives me AB, and I get this bad boy. finally, after all that work, I get the distance formula. So here's the thing about this. It looks bad. It looks like a combination of things you've seen in the past, maybe like slope, maybe a little bit also midpoint formula in terms of the way it's set up. It looks kind of similar where like I'm combining the x's and y's somehow. Also notice how this is x2 minus x1, but this says x1 minus x2. Remember that the order doesn't matter, because if I square the difference of two things, it's going to come out positive anyway. So either way you approach this should be fine. I'll show you how I would plan to get this, though, without even using the distance formula, because seeing as I'm not going to give this to you, if you resort to trying to memorize it on a quiz or something like that, you're probably going to have a bad time, because there's a lot of ways you can go wrong. Like, this could be a plus sign. I've seen people do that in the past, or they subtract. This plus sign is a minus sign, and they choose all kinds of different combinations of wrong things. So just be careful. I would, again, think of it in terms of the Pythagorean theorem. But now I ask you to find both here. So I've come prepared this time. The midpoint formula, if I say that point A is x1, y1, the order actually doesn't matter, right? Like x1 plus x2 is the same as x2 plus x1. So if I got the orders backwards, it would still give me the same answers. I end up getting -1 comma -1, which looks like it checks out, doesn't it? That falls here, which looks like the halfway point between A and B. It's never good to like use your eyes to determine an answer, but if you get an answer, it should be consistent with the diagram anyway. So it's good that it looks like it makes sense. And then with the distance formula, if I start from this and I plug in things, we need to be very careful about like subtracting negatives. If I subtract a negative thing, that's the same as adding. That'll give me 8 squared plus 12 squared, and then it's root 64 plus 144, which is root 208. I'm fine with you leaving it as root 208. I think it comes out to 14 point something or other, but remember the whole idea here, this whole thing came from using the Pythagorean theorem. So what if I just skip all this in general and just go straight to the diagram? I can count out this leg as 8. I can count out this leg as 12. We did it down here, right? Now we're already at the third step. 8 squared plus 12 squared is 208. And I take the square root of that, and I get root 208 for this. So this is one of the cases in which I feel like a visual representation, a geometric representation, a graphical one, is superior to the algebra, because with algebra, like you lose the context and it just looks like a bunch of stuff that you have to remember, and then it's easy to get lost. Whoops, I meant to cover that up. So the next page is meant to be some practice. Here, I'll give you this one for free, I guess. If I have endpoint C and endpoint W, I'm asking you to find the midpoint O of CW. Get it? When you put them together, it spells cow. So for O, this one's pretty straightforward. You just let this be x1, this 3 is x1. You let the -4 be x2. You plug things in, you do the same thing with the y's, and then you simplify. You get -1/2, you get -1/2. However, look at this one. This one's kind of weird. Given endpoints L and midpoint U, find the other endpoint B. I'm definitely going to give you a problem like this in the future, in a graded context, and it's definitely going to be tricky, and if this is your first time trying it, like on the quiz, you're going to have a really hard time. It's going to take forever, but I'm about to show you a shortcut. So if you'd like to, again, I recommend pausing the video so you can try it yourself. I would pause now, actually, and then I'll start in a couple moments. I don't know how long a moment is, but I feel like a moment has passed. You don't have to sketch this, but I'm going to do so just for some reference. But if I were to approximate where L is, 3 units, let's say that's here, 6 units would be twice as far down, so maybe here. Let's say this is L. U would be -4 and then up 3, so it's more left than up, something like this. Then here's U. So if I had to approximate where B would be, given that U is actually the midpoint, that tells me that LU is only half the segment. So if I had to guess where B is, I'd essentially be doubling the segment along the same line. So maybe that means B is up here somewhere. And it's kind of important to think about the steps that we went to get from L to U, because to go from U to B is going to be literally the same process. I've traveled the same amount of units to the left and the same amount of units up. So let's try this. Strictly in terms of the letters now. And now I'm going to avoid having things be to scale or in any kind of context. I'm just going to lay out the points and then compare the differences between their coordinates. So let's see. There's -4, 3. And I'll throw B here, but empty, because we're working on it still. Something, comma, something. So ready for this? To go from L to U, what we've done is, in terms of x's, it looks like we've traveled from 3 to -4 is 7 units left, which To go from L to U, I traveled 7 units left. Well, guess what? Since L is the midpoint, then that means since U is the midpoint, then to get from U to B, I will have had to travel 7 units left again. 7 units left of -4 puts me at -11. Can you imagine what we would do with the y coordinate of B to get it? Something pretty similar, right? To get from L to U, it looks like from -6 to 3, I traveled up 9 units. Therefore, to get from U to B, I have to go up 9 units again. So 9 more than 3 is 12. So as you can see, I didn't really need this whole graph here that I did in magenta. I just did it for reference so that hopefully everything we've done here is understandable. And that's that. So seeing as every midpoint problem that I can give you involves a segment with 2 endpoints and a midpoint, and I can give you any 2 of those things and ask for the third. So it could be like the previous problem where I give you 2 endpoints and say, give me a midpoint, or it could be like this, where I give you 1 endpoint and then also the midpoint and say, give me that second endpoint, in which case it's not as complicated as it sounds, right? You just need to know what you're doing and you need to know what these terms mean. So for number 3, for this point and this point, find SP. So remember, this is talking about finding the length of this segment or finding the distance from point S to point P. So we could do it like the straightforward algebra way, I suppose. Whoops. Oh, there's supposed to be something there. My bad. You could use the distance formula, but what I would suggest is not using the distance formula. What I would suggest is straight up turning this into a triangle, a right triangle, because horizontal is perpendicular to vertical, and then trying to find the hypotenuse of it, given that we can count the leg lengths. From 2 to 7 is 5. We can even count that, right? 1, 2, 3, 4, 5 units. From -5 to 7 is 12 units. So at this point, if I want to find what SP is, I can use the Pythagorean theorem. And actually, let me do it the way that you've heard it. So the Pythagorean theorem, again, is a squared plus b squared, equals c squared. It doesn't matter which leg I call A and which I call B, but let's call the A 5. So 5 squared plus 12 squared equals SP squared. Because again, we've created a diagram in such a way that SP is the hypotenuse of a right triangle. This is 25. This is 144. 25 and 144 is 169, which thankfully is a perfect square. So if I take the square root of 169, I end up getting 13. Keep in mind that since we're talking positive numbers here, since we're talking about distance, we ignore the fact that -13 would also satisfy this equation. And remember too that I could have plugged all of this into the distance formula that was on the previous page. I could have plugged in 7 for x1 and 2 for x2 and, plugged in the y1 and y2. And that would have gotten me there. But there's a lot of room for error in that. And with this visual approach, we're dealing with less stuff, like less variables, less numbers even. And it allows us to get a nice, clean answer that's based on knowledge rather than just plugging and chugging. So again, another page with some practice, and I think this is the last one. So maybe take a moment to, again, pause the video and try it on your own, but I'm going to proceed. Okay, now I think I can reveal these. I don't think I have to write this. Oh, good, I did it right. Okay, so in this case, I've given you 2 endpoints, and I'm asking for a midpoint. So you could plug in the coordinates. You could take the average of 6 and 9. The average of 6 and 9 comes out to 7.5. Because remember, 7.5 is 1.5 units away from each of these things. It's 1.5 units away from 6, and it's 1.5 units less than 9. Same thing with 1 as the y coordinate here. If I say find MP, remember that this is talking about the distance of this segment. So I could plug this one. I just straight up plugged in the distance formula, just to show that this is also a reasonable way to do it. But if you were digging what I did in the previous page and you want to do it that way instead, you can kind of sketch this roughly. Again, let's say, all right, that's a little too rough. Hang on a minute. Let's say here. Okay. So let's say 6, -1 is here. 6, -1. Notice how it doesn't even really have to be drawn to scale. This is pretty sloppy. Let's say 9, 3 is here. I see now I've probably drawn this too small, but that's okay. So if I want to turn this into a right triangle, because what I'm trying to find is this length right here. What did I say this was? This is M, this is P. Okay, great. So if I look at the horizontal distance, from 6 to 9 is 3, and then from -1 to 3 is 4. So again, if I just like rip this off and draw it to the side, what I'm looking at is this. Here's M, here's P. The horizontal change in coordinates is 3. The vertical change in coordinates is 4. And if I do, and like here's where it starts, here's where we see this appear in the distance formula. There's the 3 squared plus the 4 squared, then I eventually take the square root of it. We end up getting a classic 3, 4, 5 right triangle. So again, if you're willing to sketch yourself a little diagram, then you actually don't even have to worry about remembering the distance formula. You just need to know the Pythagorean theorem, which isn't so hard, is it? A squared plus B squared equals C squared. Then I go a little bit further, though, and I say, find the point Q such that P is the midpoint of MQ. So here's M, here's P, just from the previous picture I drew. Q is a point such that P is the midpoint for MQ. So in other words, here's M, here's P. Q would have to be somewhere over here, such that P is in the middle of the two. So then I can kind of do that thing that I did on the previous page, like how much more is, or how far right have I gone from M to P, and how far right will I have to therefore go from P to Q, because that's going to be the same number. I could do the same thing with the Y's in terms of going up and down, easy peasy. I just wrote it out like this. To go from 6 to 9 is an increase of 3. If you increase by 3 again, you get to 12. Same thing with the Y's. I increased by 4 and then increased by 4 again to get 12,7. I think that's it, right? Yeah, that's it. All right, I hope this makes sense to you guys, but we'll talk about it more in the near future, so thanks for watching, folks.